Hello again, statistics students. My name is Jamie Amy, and this is section 1.2 on types of data. A parameter is a numerical measurement describing some characteristic of a population. So it's nice that these both start with the letter P. It's helpful in remembering that whenever you guys do like your entire population and you crunch numbers based on the data, those numbers that you crunch, like the average, the standard deviation, the mean, those are called parameters because they come from the entire population. Contrary to a statistic, that is, you've crunched the numbers and you did so based on just a sample of your population. And those both start with S, so that's kind of nice to help you remember too. Statistics come from if you surveyed a sample of the population. Qualitative data consists of categories. So an example would be genders of professional athletes. Versus quantitative data, that consists of numbers. For example, the weights of supermodels. Now, if you're in quantitative data, it can either be discrete or continuous. Discrete quantitative data, one way to think about it is whole numbers. It results when the number of possible values is finite. So for example, the number of eggs a hen lays. 1, 2, 3 eggs counted in whole numbers. Continuous quantitative data is results when the number of possible values is infinite. So for example, the amount of milk that a cow produces, that's measured in gallons. So we would measure that as 2.8 gallons, 2.9 gallons, 2.95 gallons. So if you obtain data based on the amount of milk that a cow produces, you would have obtained what is called quantitative continuous data. There are different levels of measurement. For example, the nominal level, that's when data consists of categories or labels only, and the data it's not arranged in some order like better to worst or low to high. So an example would be survey responses. You're asking people to respond with yes, no, or undecided. And if that is what your data results look like, how many people said yes, how many people said no, how many people were undecided, then you have what is called a nominal level of data. Ordinal level of data can be arranged in some order, and the differences between the values it's immeasurable or meaningless. Let's talk about this example to help explain. The course grades based on letters would be A, B, C, D, and F. So these can be arranged in order from passing to failing, best to worst, however you want to think about it. But the difference between an A and a B, if that's all I know, if I know one student got an A and one student got a B, I don't know the corresponding percent that those students got in a class, then I can't measure the difference between that student's A and the other student's B at the ordinal level of data. If I figured out the percentages and that's the data I was gathering, then I could measure the differences, and that would take my data to what's called interval level. That's data that can be arranged in some order, and the difference between the data values is measurable or meaningful. So percentages of grades. One student got 95%, one student got 94%. I can measure that's a 1% difference. That would be interval level. Here's another example. Temperatures of water, 70 degrees, 80 degrees, 90 degrees. Those can be arranged from coldest to warmest, and you can measure the difference between each of your data values. And the last level is called the ratio level. That's when your data, it's made it to the interval level, okay? But then it has this additional property that there is a natural zero starting point to it. So one example would be like the prices of college textbooks. If you're in a class that gives you the textbook for free. That would start at $0. So that would represent no cost. Okay. This one can be a little tricky. Just think about if 0 is a natural starting point and if 0 represents none of those particular units, then you know you have ratio level. Let me elaborate a little bit. Why aren't these temperatures of water? Why don't those make it to ratio level? These are at interval level, but they don't make it to ratio level because if I told you that the water is 0 degrees, that is a temperature of water. It doesn't mean that there is no temperature. It's a quite cold temperature, actually. So this degrees of water does not make it to ratio level because 0 degrees does not represent no temperature to the water. And it's not like all water starts at 0 degrees. So maybe that will help you differentiate between those when you get to those questions on the homework. Let's try a few examples here together. 1. After inspecting all 55,000 kilograms of meat stored at the worst sausage company, it was found that 45,000 kilograms of the meat was spoiled. Is the given value a parameter or a statistic? Okay, so is our 45,000 kilograms of spoiled meat, is that a parameter or is that a statistic? Little reminder, it's a parameter if it comes from a full population. It's a statistic if it was a sample from a population. What did ours come from? Well, our found 45,000 kilograms of spoiled meat came from expecting all 55 kilograms from the sausage company. So since all of the meat, that's the key word, you guys, all. So you know you were looking at the entire population. So this 45,000 kilograms, that's a parameter because it came from the full population of interest, not just, okay, we sampled 1,000 kilograms of meat out of the 55,000 kilograms. That would have been a statistic. So number 1, parameter. Number 2, the weights of Bill's pack as he sets off on a backpacking trip is 48.3 pounds. Is that given value from a discrete or continuous set of data? If you need to look back a little bit, do so on the difference between discrete and continuous. And if you come up with continuous for this, you are correct. That is because pounds is a continuous set of data. When data is in pounds, it is a continuous set, rather. 48.3 pounds, 48.35 pounds. Those are all reasonable outcomes when measuring the weight or in pounds of an object. Determine which of the 4 levels of measurement, nominal, ordinal, ratio, or interval, is most appropriate. Okay, first one, salaries of college professors. Do you guys think that's nominal, ordinal, interval, or ratio? If you said ratio, you got it right. If you said interval, you came up with the most used incorrect answer, but it's understandable if you came up with interval. Ordinal, we wouldn't, hopefully you didn't come up with ordinal or nominal. Let me try to elaborate. Salaries. What unit do we measure salaries in? Answer is dollars. So when you think about dollars, if you're recording dollar amounts, are you recording nominal, ordinal, interval, or ratio level? And the answer for whenever you're recording dollar amounts, you have ratio level data because $0 represents no dollars, so none of that unit, and $0 is a natural starting point. Okay, I know that sounds a little tricky, but you might be thinking to yourself, well, there's no professor out there that makes $0. They don't start professors at $0. Okay, you're on the right track, but you can't think about the exact scenario. It's not about how much they pay each college professor. It's rather about the unit, the dollar, Okay, so now whenever you guys see a homework question that has to do with dollars, it's ratio level data. The scenario does not determine the level of data. I know that can be a little tricky. Think about it. Practice a few more in the homework. It'll start to sink in. Survey responses of good, better, best. Do you guys think that's nominal, ordinal, interval, or ratio level data? Turn back to your slides on those terms if you need to. If you said ordinal level data, you got it right. Ordinal is when we can put those data values in some type of order. For example, good, better, best. That's increasing, okay? But we can't measure, like if one person said good and another person said better, we don't have a measure, like a way to measure the difference in how good or how, the difference in how good someone thought the movie was versus how much better someone thought the movie was when we've only asked them to respond with good, better, best. How do we ask them to respond with rate the movie between 0 and 10, and I rate it 7 and you rate it 8? Then we could measure. That would bring us up to interval level data. But survey responses like good, better, best, ordinal level data. Try the last one. The subjects in which college students major. Is that nominal, ordinal, interval, or ratio level data? If you said nominal, you got it right. You cannot arrange the majors that different college students choose from better to worst. Okay, it's a selection based on their preference. You can arrange them, say, in alphabetical order. You can arrange them, say, in which one has the average, highest annual salary. Okay, but that's not the type of data we have. We're not looking at the annual salary. We're looking at just the major selected. Those are categories, and that would be nominal level data. All right. If you got all 5 correct, nice job. If you're struggling on some, you might want to turn back a few slides, read through those term definitions and examples again before you try any homework from section 1.2. Let's talk about 1.3 on collecting sample data. So once you determine the type of data you want and need for your study, you got to go out there and collect it. And there are different ways to do so. Maybe you conduct an observational study. That's observing and measuring specific characteristics without modifying the subject being studied. So for an example, the Pew Research Center surveyed 2,252 adults and found that 59% of them go online wirelessly. So that is just an observational study. That is what they observed. They didn't try to intervene in any way to change those results. Different types of observational studies are cross-sectional, and that's when the data is observed, measured, and collected at one point in time. So the study above, the example from the Pew Research Center, that was a cross-sectional study. They likely just figured out at that moment how many of you 2,252 adults go online, and they got their results. But that's not the only way to gather data for an observational study. You may want to look or think about, well, what's going to happen in the future? We want to see how our data looks, not right at this very second, but in the future. That would be called a prospective type of study. Data are collected in the future from groups sharing common factors called cohorts. So for example, if we called our particular class a cohort, because maybe we're trying something new, then we would look in the future to see how you guys are doing later in life based on what you did in that particular cohort. So it's a prospective study. Opposite direction, past data. That is called a retrospective study. That's when data are collected from the past. We cannot travel back in past. I know that, so you might think, how is that possible? It's about going through old records, old files, examining those records, or maybe finding people who experienced something that occurred in the past and interviewing them. So you're looking at past data. So cross-sectional, perspective, and retrospective, those are all 3 types of observational studies. Let's try one. What type of study would collect casualty data from the Great Flu epidemic of 1918? Do you think it's cross-sectional, perspective, or a retrospective study? If you said retrospective, you got it right. So we'd be looking back for some reason in retrospect. What could we have done differently? Maybe that was their mission for this particular study of the Great Flu epidemic of 1918. Okay, now if you are not just observing and you're going in there and you're trying to modify your results, then you're conducting what's called an experiment. That's applying some treatment/modification and then observing its effects on the subjects. For example, in the largest public health experiment ever conducted, as of the time this was published, of course, 200,745 children were given the Salk vaccine, while another 201,229 children were given a placebo. Okay, so what we have done here, that particular example, is an experiment. 3 things, if you want to design an experiment, there are 3 main things you want to not forget to consider. 1, you want to use randomization to assign subjects to different groups. You don't want to get an entire group of a certain age or certain living environment. You don't want to put them all in one group, because then you're not randomly selecting those groups, and you may be throwing factors in there, common factors for the groups that you don't recognize. So make sure you're doing randomization when assigning your different groups. Computers can be helpful in that. Number 2, you want to use replication by repeating the experiment on enough subjects so that the effects of treatment or other factors can be clearly seen. So make sure to have a large enough sample size and to replicate your experiment enough times to make sure that any outliers get thrown out, because you've replicated it enough times that those outliers will identify themselves, and you know that you need a larger sample or to continue replicating the study to be sure that all other factors are clearly seen. You need to do your best to control the effects of variables. Okay, one way to do that is to use a technique called blinding. That's a technique in which the subject does not know whether he or she has received the treatment or the placebo. Placebo means fake, you guys. If you think, what's placebo? It's like a fake. So maybe it's like a sugar pill. So if you don't tell your subject if they've received the pill that has an effect, or you think it has an effect, versus the sugar pill, then you've done a technique called blinding. And reasons for that, well, you're trying to control the effects of your variables. Maybe you don't want your subjects to know, oh, I just got the sugar pill, so I'm going to respond or react in a certain way. Double blinding is when neither the subject nor the experimenter knows whether the treatment or placebo has been administered. And this is an effective technique to help control the variables, because not only does your subject not know if they have the sugar pill or not, and therefore they won't respond based on that knowledge, but the person maybe observing them, interviewing them, reading their answers to something afterward, the person also isn't aware if that subject had the real treatment or the placebo, so they wouldn't be looking at their results in a jaded way, if you will. Different types of sampling are random, And that is where a sample of n many subjects are selected, and every subject has the same chance of being chosen. Okay, that's a good thing for us statisticians. So there's also systematic sampling. That's where sampling every kth element of a population. So maybe you're driving into an airport and security is stopping every 10th car. Here we have this line of people, and it looks like every third one is being selected for the study. That's called systematic. You've come up with a system. Convenient sampling is when you're using results that are easy to obtain. So here this lady is yelling out her window, "Hey, do you believe in the death penalty?" to this man walking his dog. That's convenient sampling, and whatever she obtains from that sampling method there, she should only use as a projection on how this man felt about the death penalty at that time while walking his dog. Okay. Stratified sampling and cluster sampling. These two are often confused, so I want to present them at the same time. They're similar in that they group their population right off the bat. So for example, here we've grouped the population by women versus men, okay? That's the common factor, women and men. Here we've grouped the population according to precinct. So precinct 1, precinct 2, anybody who lives here is in precinct 3, anybody who lives here is in precinct 4. Okay, so both stratified sampling and cluster sampling group their members in some way. So that's the similarity and the reason why I believe they get confused. Now here's the difference though. If you're doing a stratified sampling, you would go to your first group of women and you'd talk to some of them. You'd go to your next group of men and you'd talk to some of them. You'd go to your next group, should there be another one, you'd talk to some of them. You'd go to every subgroup you created and you would talk to some of them. That's stratified sampling. Cluster sampling, on the other hand, you've grouped them, but then you select a few of the groups, precinct 5, 16, and 28. Now, when you go to precinct 5, you survey all the members in that precinct. Precinct 16, talk to all of them. Precinct 28, talk to all of them. That's the difference between stratified sampling and cluster sampling. You'll see some good examples in the homework. Take your time with them, talk them out with other people. They'll start to make more sense the more you work with them. All right, let's try a couple examples together. Identify which type of sampling is used. 1. At a security checkpoint at a government facility, every 10th individual was more likely searched than the others. What do you guys think that type of sampling is called? If you said systematic, you are correct. Every 10th. Whenever you see something like 3rd, 10th, 100th, think that might be the systematic sampling method. Number 2, the name of each contestant is written on a separate card. The cards are placed in a bag and 3 names are picked from the bag. What type of sampling method do you guys think that is? If you said random, you got it right. Every contestant has the same chance of being selected, 1 out of however many people are in that group. Number 3, the population is grouped into 10 cities. A market researcher selects 500 people from each of the cities to interview. Okay, look back a slide, look at the graphics, try to think about this one. Hint, start with something that a sampling method that groups into 10 different cities or 10 different groups. So we're doing some grouping. So I hope you're thinking stratified or clustered. Grouping into 10 cities, we're either stratified or clustered. Now, as we go on, a market researcher selects 500 people from each of the cities. That makes it stratified. They went to each of the 10 cities and talked to 500 people. That makes it a stratified sampling method. Last one, an education researcher randomly selects 48 middle schools out of 2,000 and interviews all of the teachers at each of those 48 middle schools. Look back, think about this. Is it convenient sampling, systematic, random, stratified, or clustered? If you said cluster, you got it right. So we have 2,000 clusters. They're all the different middle schools. And this particular researcher goes to 48 of the middle schools and talks to every teacher at those 48 schools that they chose, cluster sampling. And that will finish our lecture video for the day on section 1.2 and section 1.3. My name is Jamie Amy, and I will see you next time for our video lecture on chapter 2.